This is 4.7 L'Hopital's number 37. So the limit of the top, let me show you. Clearly, that's going to be infinity. Hopefully you can see that. If you don't see that right away, you're confused because you're going to get infinity minus infinity. That infinity is way bigger, so it overpowers that one. But we could probably show it another way, I think, to convince you that it is infinity. We're going to factor out x squared, and we're going to get 3x squared minus 1. Did I do that right? Let me double check. Yes. So clearly, this is infinity, because infinity squared is infinity. This is infinity, because infinity squared is infinity. Both of those are infinity, and subtracting 1 from infinity doesn't do anything to it. So infinity times infinity is infinity. So clearly, the top's infinity. And the bottom, pretty obviously, is infinity, because infinity to the fourth power times 6 plus 12 is infinity. So therefore, L'Hopital's applies. Now, just as a side note, when we did this in chapter 2, we didn't have L'Hopital's because we did no derivatives. And in chapter 2, we would have looked at the exponents here and divided top and bottom by x to the fourth. You take the degree of the denominator and then divide top and bottom by x to that degree or that power. That's how we did it in chapter 2. We now will apply L'Hopital's. So using L'Hopital's, we say the limit as x goes to infinity. The derivative of the top is 12x cubed minus 2x. The bottom is going to be 24x cubed plus 0. All right, we're going to have to do L'Hopital's 3 more times. So in this case, it's actually faster dividing by x to the fourth. It comes out quickly. But to do L'Hopital's again, I have to show that it applies. So I have to do this. I take the limit as x goes to infinity of 12x cubed minus 2x. Again, some of you might be confused because that's infinity minus infinity. But again, we can factor out an x, 2x. And we're going to get 6x squared minus 1, which clearly is infinity times infinity, which is infinity. And the bottom, we take the limit, and that's infinity. So you may say, why do you write that down? It's so obvious. Because I have to show why I'm allowed to use L'Hopital's. And first I have to show that the top and bottom both approach infinity. Therefore, by L'Hopital's, this is going to equal, I'm going to take the derivative of the top and bottom. It's going to be 36x squared minus 2 over, 24 times 3, that's 72, I think, hopefully. Now, again, we run into the same problem. So we have infinity over infinity. I'll have to show you the limit as x approaches infinity at the top is infinity, and the bottom, this is so tedious. So therefore, L'Hopital's applies again. So I can say this equals the limit as x goes to infinity of 72x over 144x. Now, something nice happens at this point. We can cancel the x's out. We couldn't prior because it's 2, so I couldn't cancel these, but now I can cancel these and I have my answer. So this is going to be 72 over 144, which is 1/2.